All right, to kind of pick up where we left off, we were talking about how to write vectors in a component form. This right here is basically a directed line segment in a different way of saying vector. Component form, again, is just written with the little inequality symbols. And you can do this mathematically or just count as well. But if I look at AE, which is located right here, remember you go from the terminal point from the initial point. So what is -2 minus 0? All right. And then what is 6 minus 0? 6. So again, going from that terminal point, which is the ending point, to the point that has an arrow, and the initial point is the point that doesn't have an arrow, it's the starting point. So when we got to name the rest of these, so we do the directed line segment BH. So here's the beginning, here's the end. So I'll go -2 minus 6. And what do I get? Very good. And I'll go -8 minus 4. Perfect. Then we'll do the directed line segment for DC. You go right here. So that would be, again, here's the initial, here's the terminal. So what's 4 minus 0? What is 6 minus 8? Very good. And then do the directed line segment for GF, -8 minus -4. Very good, because that would make it a positive. And then what is 0 minus -2? +2. Good, because again, it makes it a positive. Directed line segment IG. Nope, that's a J, IJ. So again, here's where I start, here's where I end. So what's 8 minus 2? 2 minus -6. Very good. Any questions on how to write it in component form or how to read it in a graph? Okay. Had this graph not been here, remember the first letter represents the initial point, the second letter represents the terminal point. So if you're given the coordinates but not the graph, then you know which one you're subtracting, the second from the first. All right. So let's move to number 5. So if we consider the points P, Q, and R, we need to compute P and Q and P. And then we're going to show that PQ plus QP ends up being the 0 vector. And I'll talk about that. And we'll do it geometrically as well so you can visually see that. So to start off with PQ, again, not given a graph. It just tells me to find this. Since Q was the second letter, I'll take the -3 first minus the 2. Does everyone understand that? All right, so then -3 minus 2 gives me -5. Very good. Then I'll take the 3 minus the 1. Very good. And you get 2. So there's PQ. Now we're going to do QP. I'll do it a different color. Again, now notice this time P is the second point, so that's where I'll subtract first from. So what is 2 minus -3? +5. And what is 1 minus -3? -2. Go ahead. Initial point. Yes, always true. Oh, it won't be written for a directed line segment like that. It's usually always written like this. They'll switch the letters to put it in the appropriate. Now, on the graph, obviously it might be going that way, but to write it out, it'll be written like that. That's a good question, though. Any others? If that ever does happen, though, we'll still assume the second, where whoever has the arrow will be the second point. So let's say it was written like this. And I haven't really seen it, but I'm not going to put it past people. If I write it like this would be the same thing as QP like this. So that would be the same thing. So if you ever do see it like that, maybe in a math book or on an SAT test, and they're trying to confuse you, those would mean the same thing. Those are good questions. All right, now that I found PQ and QP, it wants me to add PQ and QP. Remember, to add vectors, we just add their corresponding vectors, values. So what's -5 plus 5? 0. And what's 2 plus -2? 0. So did we just show that it was the 0 vector? All right, let's explain why. All right, here's a graph. P is 2, 1. And Q is 1, 2, 3. And then I'm not even graph R because it's not needed. But if I first graph, or this is P, this is Q. If I first graph PQ, I would go in this direction as a vector. And then as QP, I would then go right back there. So when you're in physics, you talk about total distance and displacement, right? Those are the two major things that you'll talk about. It's also what we talk about in calculus as well. It's a big thing. But you can see that the displacement, so if I start at P and I go to Q and I go back to P, how far did I move? I didn't. So therefore, my displacement should be 0, 0, meaning I did not go left or right. So that is why geometrically it gives you 0, 0 as well. Any questions on that? Awesome. Let's move on to part B. Part B says plot the points P, Q, and R. Use the diagram to explain why PQ plus QR plus RP is the 0 vector. And then we'll show it by adding them all up as well. All right, so we want to do a diagram first. What was P again? Thank you. What was Q? Was it 1, 4? Thank you. All right, so what we're going to do here is we're going to use a diagram to explain why this right here ends up being the 0 vector. So let's get different color going on here. So PQ would mean I go from P and I travel to Q. QR would then mean I go from Q and I travel to R. And then RP would mean I start from R and I travel to P. So again, talking about displacement, if I started at P, then I went to Q, then I went to R, and then I went back to P, what would my displacement be? 0, 0, which is why you get the 0, 0 vector. Now, algebraically, let's figure this out as well. PQ, we already got the answer to this one. What was PQ? All right, let's quickly find QR. So again, QR looks like I went over 1, 2, 3, 4, and then up 1. Agree or disagree? Yep. All right, that was wrong. What's the correct answer? Totally kidding. That's right. Again, just makes you don't agree with me. I've been wrong I've been wrong before. All right, RP, I go over 1, and then I went down 1, 2, 3, so that would be -3. Good to represent down. So if I wanted to show this algebraically, I would just simply add these vectors up. So even though there's multiple vectors here, you still add their corresponding values. So what's -5 plus 4 plus 1? 0. What's 2 plus 1 plus -3? 0. So you can see geometrically and algebraically, if you go back to where you started, you get the vector 0, 0. Go ahead. You noticed? Yes. So for this to work out, the inner letters have to be the same, because then what happens is, if, let's say I did PQ and then I wanted to do RP, notice I would have to take the RP vector and put it here. Now I'd be located right there somewhere. And then if I then did QR, oh, you know what? I bet it would still work out, because then I would put QR here and it'd probably take me there. So I guess maybe it doesn't matter, as long as overall I can rearrange it so that the inner letters are together. Yeah, because that's a good question. Because just doing that real quick in my head, if I was to do PQ and then RP first, this is a rough sketch, but I'd be like, Yeah. So let's do that. So let's go over 1, and then down 3 is about right here. And then if I go from then, I do QR. So I'd go 1, 2, 3, 4, up 1. Alternatively, I do end up in that same spot. And that also means too, we know addition's commutative, so the order doesn't matter. But yeah, but as long as I can rearrange it in a way that the inner letters do match, then I know I can get to the same place. That's a really good question. I like it. Any others like that? Alrighty. So let's move on to example 6. In example 6, we're going to show that for any 2 points A and B, the negative AB does equal BE. What's that negative in front of that? Let's take this back. Not quite. If I take V, what would be negative V? Whoops. There it is right there. It'd be the opposite, which you would distribute the -1. Yes, that's how you do it mathematically. But that vector itself is called the opposite vector. So since I know that directed line segments can be written as a vector, they would share the same rule. So I'm just going to kind of quickly go through this, and let's say A is A1 and A2, and B is B1, B2. Right? If I wanted to do A to B, so negative AB. So you would start off with I would just carry the negative for now. But if I did the AB first, this will then be B needs to be subtracted from A. So that'd be B1 minus A1, and then B2 minus A2. Now, when I distribute this negative, what could I do with those binomials there? When I distribute a negative into all of it, what's that B1 going to become? A negative. And then what would that negative A1 become? So couldn't I just rewrite it as A1 minus B1? I mean, it's the same thing as saying negative A1, negative B1 plus A1, right? It makes it look cleaner. So that's what I'm going to do. So anytime you multiply by negative and you have a subtraction going on, I can just switch it. So this now becomes A1 minus B1 and A2 minus B2. All right, so that's what that left side is. Let's do the right side. So if I do BA, this time A came second, so that's what I need to start with. So that would then be A1 minus B1 and A2 minus B2. So is this the same as this? Yes. So you just showed that any 2 points, the opposite of AB would be the same thing if I rearrange the letters as BA. So now that's a fact that we know, and we can stick with it, and we don't have to show it again. I'll go with this. You could have also plugged in numbers to show it as well, but this works out for every single case. So let's look at number 7. Number 7 says, given the vectors v, w, and t, we're going to verify the sum of these 4 vectors is 0. So I'm going to give you all an opportunity to do that real quick. How would I verify that these vectors equal 0? What do I need to do? How do I add vectors? What do you mean by that? Good. Add all their corresponding x's, add all their corresponding y's. Go ahead and verify that real quick to make sure you can add correctly. That's it. Add them together to make sure that you get the 0 vector. If you didn't, check your math. And did you all get 0, 0? Anyone nuts? Perfect. Again, 2 plus -5 gives you -3. -3 plus 4 gives you 1. And then 1 plus -1 goes back to 0. -3 plus 1 gives you -2. -2 plus -2 gives you -4. -4 plus 4 gives back to 0. So we're all good there? Awesome. So that does mean if I was to take each one of these, I should end up back as a displacement of 0, 0, meaning I did not move. I started right back where I began. All right, so we're going to show that geometrically now. So again, we're going to draw a diagram representing the vectors as arrows placed end to end to support why their sum would be the 0 vector. So again, we'll start off by graphing V. V was 2, -3. Then we're going to graph W. So that's -5, 1. Oh, I lied. Hold on. All right, okay, hold on. If I graph 2, -3 to start, this is where I would start. And then from this point, because we gotta go end to end, I need to go from here and go left 5/1. So that'd be 1, 2, 3, 4, 5. These are vectors now, not coordinates. Oh, my bad. 5, +1. Let's go up right here. Too bad they don't give us a grid. So this would be W. And then from here, we're going to graph U. So now we're going to go right 4. So that's 1, 2, 3, 4. And then down 2. So like right there. That would be U. And then from this, we're going to go left 1 from there. And then up 4. 1, 2, 3, 4. So again, if I started from the origin and then I graph vector V, then vector W, then vector U, and then this was T, and then vector T, you can see I go right back to the original spot, which is the origin. So that's a demonstration. If we had better graph paper here, you might have a better illustration there as well. Any questions geometrically? All right. So we have what we call the parallelogram rule for vector addition. So we're going to kind of draw it out so you can show that we can actually do a parallelogram. We've done this, I feel like, in the past, but they're just giving it new names. So when the initial point of a vector is the origin, then the coordinates of the terminal point will correspond to the horizontal and vertical components of that vector. This type of vector with initial points at the origin is often called a position vector. So let's draw it out first. We'll draw the arrows representing vector V. Y'all got grid paper on y'all's too this time. Oh, this should be a lot nicer looking. All right, here's 5. Here's 3. There's my vector V there. And then we're going to graph U, but we're going to use the initial point 0, 0. So then U would be graphed from origin as well. So then 1 to 7. One thing I never understood about vectors, why V and U? Gosh, they can sometimes look exactly like the same if you go real quick. Why didn't they just choose like X and Y or something? But that literally in any calculus class you take up to this point, that's what you'll see. U and V, U and V, U and V. And it's like sometimes when I go fast in my notes, I'm like, why did I do U plus U here? Like, where this other, why did I do it? And that's so I get confused sometimes. So make sure you kind of put like a tail on it or something with that U. All right, so now we're going to add V plus U graphically. So that means I graph V, and then from V, I'm now going to graph U. So from this point here, I'm going to go over 1, and then up 1, 2, 3, 4, 5, 6, 7. So this will be my U. And then we're going to do the same thing. We're going to do V plus U. So from, oh, wait, what is V plus, oh, gotcha. V plus U would be this guy right here. V plus U. And what's that coordinate there? There you go. I used to listen to that radio channel on AM radio there for the longest. Y'all even know what AM radio is? Y'all got Sirius XM these days. Never had a life without it, huh? All right, so we drew the arrow. We made v plus u, again, from the origin, so we have a coordinate. Then we do the same thing for u plus v. This time I start at u. I'm going to graph v, so I'm going to go over 1, 2, 3, 4, 5, up 1, 2, 3. So I can see I do land in the same spot. So this will be v, and this happens to also be u plus v. All right. So with that, you can now see what kind of shape do we have. Parallelogram. A rhombus there would be a square that is diamond shaped. A what? Oh, we did that one class. Yeah, I did. I try to do it with diagonals. But it's just base times height. All right, so there you go. So that is this parallelogram. If you take the u plus v and the v plus u and you graph both of them together, it can actually produce a parallelogram. So let's put that to practice real quick. That was just an example. So in exercise 8 through 10, good? Okay, cool. In exercise 8 through 10, we're going to let u be a vector, v be a vector. We're going to draw the diagram to illustrate v and u, and then find v plus u using this parallelogram rule. All right, y'all go ahead and draw it out and then figure out what that v plus u is. All righty, do we got the answer, we think? Give you a little bit more time. All right. So if I'm looking for v plus u, I need to first graph v. So from the origin, I'll go over 1, 2, 3, 4. 1, 2, 3. So here is my v. And then I'll graph u at the end of v. So now I'm going to go left 2. So 1, 2. And then up 5. So that's 1, 2, 3, 4, 5. So over 2, 5. This would be my u. Now to find v plus u, I just got to find the vector that attaches from the origin to said value. And what value is that? Very good. You can verify that by math. What's negative 2 plus 4? 2. And what's 5 plus 3? 8. Be able to graph something like this, you're going to have to graph it on the test. So be able to graph vectors. from end to end or tip to tail. Go ahead and try B real quick. See what you produce. You can always do the algebra to make sure your answers end up where they're supposed to, and then graph it correctly. Anyone stuck on how to graph 2V? Alrighty. Due to time, I do need to start going over this. To graph 2V, the way you have to do this graphically is graph V first. What was V again? Okay, so you go 1, 2, 3, 4. 1, 2, 3. So you start there with your first V. And then from that V, you graph another V. So 1, 2, 3, 4. 1, 2, 3. That will then produce 2V. Then from there, I can then graph U, which was negative 2, 5. So 1, 2, 3, 4, 5. Go over 2, up to 5. So when I'm looking for 2V plus U, this is where that would be. 2V plus U. And what is 2V plus U? 6 and 11. Good. At least it's 6 and 1. Perfect. Any questions? All right, that is the bell. They seem to have those off still. So y'all enjoy the rest of the day. We'll finish this discussion and start lesson 20 tomorrow. Make sure you get 18 done. Just turn it at my corner of my desk. If you did not get it done, you can email me before midnight tonight. And don't forget to turn in the workbook.